Okay, let's try problem 8.41. A man is attempting to raise a 7.5 meter long, 28 kilogram flagpole that has a hinge at the base by pulling on a rope attached to the top of the pole, as shown in the figure. With what force does the man have to pull on the rope to hold the pole motionless in the position? Okay, so this is just another sum of all torques is equal to 0 problem. Right, because we want to hold this pole motionless so we can't have any torques acting on it. So first let's go ahead and identify the torques. There's going to be one torque, which is going to be due to the weight of the pole, called W sub P. And there's going to be another torque due to the man pulling on it, called T sub M. And so we know that T sub M, right, if this guy's pulling on it, it's going to try to rotate this pole counterclockwise. And the weight is going to try to rotate it this way, right? It's going to try to rotate it clockwise. So we know that the torque from the man must be equal to the torque from the pole. And so let's go ahead and solve for the torque from the pole. So the torque from the pole is going to be equal to force times the radius times sine theta. So the idea with this is to try to find the force that's perpendicular to the pole. So we want to find the force, the component of the weight that points in that direction. So we're going to stray a little bit from the sine theta, and we're going to look at some trigonometry right now. So we know that this angle right here, right, is 30 degrees. We're given that. But that also means that this angle across from it has to be 60, because this is 90. So that also means that this angle right in here has to be 30 as well. And so if we make this triangle right here, like we've done in previous chapters with things rolling down hills and trying to find the component of a weight, we can see that if we take the cosine of that to find the adjacent side right here, change angles, getting a little complicated, getting a little crowded. If we're trying to find that right there, we can do the cosine of 30, right? So what we're really trying to find is going to be equal to the force perpendicular times r. And to do this, we know that the weight, the component of the weight is just going to be the cosine over here, right? Because it's the adjacent side. So it's going to be equal to the mass of the pole, m sub p, times gravity, times cosine of 30. Because that's going to give us the component of the weight that is perpendicular to the pole. And then we want to multiply this by the radius to get torque. But the radius is only going to be 1/2 r, right? Because it goes from here to over here, so it's only going to be 1/2 r. Okay, so now let's find the torque from the man. This is going to be equal to F r sine theta as well. Or again, we can think it about the same way. The force perpendicular times r. This little upside down t is what means perpendicular. And so this is going to be equal to force. And right here we can actually use sine, right? Because we want to find this. We want to find the force that's perpendicular. So he's going to be pulling this way. We want to find the component that's in that direction. So that's just going to be sine theta. So F times sine of theta, which is going to be 20 degrees, sine of 20, times the radius. And so the radius is going to be the whole length. It's just going to be r. And so now we can go ahead and set them equal to each other. M sub p times g times cosine of 30 times 1/2 times r is going to be equal to F sine of 20 times r. So r is going to divide out. And then I'm going to go ahead and divide through by sine of 20 to get f by itself. So f is going to be equal to mp, it's the mass of the pole, times gravity, times cosine of 30 times 1/2. This is all going to be over the sine of 20, right? So what is this F? This F is going to be the force that the man's pulling on the rope. And so this is actually going to come out to 1/2 times the mass of the pole, which is 28 kilograms, times 9.8 meters per second squared, times the cosine of 30, all over the sine of 20. And when you plug that into your calculator, you get F is equal to 350 newtons. So that's the force that this guy is going to have to pull to keep this pole motionless. And that's problem 8.41.